Today we were talking about the specific transformation called reflection. Okay, a reflection is a rigid transformation, which means that the size and shape stay the same. And that means they are congruent. So when the size and shape stay the same, that means they are congruent. Okay, so let's take a look here. The graph of a trapezoid A, B, C, D is shown. The graph of the image A, B, C, D after a reflection across the x-axis. Write the coordinates of the reflected image. Okay, so if we think about a reflection, think about a mirror. Okay, when you put your hand up to the mirror, the reflection in that mirror shows your hand the same distance from the mirror as your hand actually is. So the distance that is shown is the same. So that means whatever we're being reflected by, it's the same distance away. Okay. So if I am reflecting this figure here, A, B, C, D, I'm going to do one point at a time. And this says reflection across the x-axis, which means I am going to go across the x-axis, which means in this case, I'm moving it up. Okay. And now the distance here between A and X is 2, which means the reflected distance needs to be exactly the same. So 2 spaces here, well, then it's going to be 2 on the opposite side, and I'm going to plot my point there. Also recognize point point A here is at -2, -2. When I reflect it and I move it to the same distance across that x-axis, my new point here, A prime, becomes -2, +2. So I take the opposite of my y value. Okay, so when I reflect across the x-axis, my x value stays the same, and my y value, I take the opposite of it. Okay, and I indicate that by a negative sign there. Okay, so let's do the same thing for point B here. So point B, again, reflections, they're the same distance from the line of reflection. In this case, the x-axis is my line of reflection. So 1, 2, 3, 4. So I'm going to go +4 here, and that is going to be point B prime. Okay, and so I went from -3, -4 to B prime, which is going to be -3, +4. Okay, so again, using that same coordinate notation where you have your x value and then you take the opposite of the y value, the opposite of -4 is +4. Okay, the opposite of -2 is that +2. So we're going to do the same thing here for C, which is at +3, -4, and D is at +1, -2. Okay. And I'm going to take the opposite of my y value. So C prime is going to be plotted at +3, and then it's going to be at +4. So I'm going to go +3. Oops, not 3, 2. 2. Here, this is actually 2. See here, 1, 2, and down 4. Okay, so it's +2, -4, and it becomes +2, +4. Okay, and you can see it's exactly level with your B prime or your B, which means C prime is going to be level with B prime. Okay, and then same thing with D, 1, -2 becomes 1, +2. Okay, there's D prime. And then when we connect those, they look exactly the same. Plot that. 1, +2, so that's D prime. And then when we connect our lines here, our shape should be exactly the same size and shape. Do the same thing here on number 2. The graph ABC is shown, the graph image of ABC after reflection across the y-axis. So so this is our x-axis is what we just did. Okay, so we took the opposite of my y value. So if we go across the y-axis, we are going to take the opposite of the x value. Okay, is going to be your coordinate notation there. Okay, so A, again, a reflect across the y-axis, so it's 3 away, which means it's going to be 3 away from the axis on the other side, which means it's going to be -3. So A is +3, +2, so 3, 2. And when we reflect it, it's going to become -3, +2. Okay, B is +1, -1, 1, -1. And then when we reflect it across the y-axis, it's going to remain 1 away, so it's going to be -1, -1. And again, that's the opposite of the x. And then C is +4, -3, and that is going to become -4, -3. And then when we connect our dots, same size and shape. The triangles, when you reflect across the y-axis, kind of look like wings. Okay, so you can try 3 and 4 on your own. Do a couple more down here. This one, the graph PQR is shown. The graph of the image of PQR after reflection across the line y equals 4. Remember, if y equals 4, it's a horizontal line, 1, 2, 3, at y equals 4. Okay, so we get a horizontal line right there. That's our reflection point. And remember, the distance is exactly the same. Okay, so this becomes P prime. It's 1 away from that line of reflection. Okay, R is 1 away from that line of reflection. So again, we're just going across that line. And Q is 1, 2, 3 away. So it's going to be 1, 2, 3 away. Okay, so R prime, Q prime. Okay, you probably won't see too many of that type of problem, but those are there. And then x equals 3 is going to be a vertical line at x equals 3. I'll let you try that one on your own there. Okay. Okay, let's take a look at number 13 here. Polygon ABCD has coordinates as there. The polygon is reflected across the x-axis. Write the coordinate notation for the reflection, then write the coordinates. So that coordinate notation is what we're talking about. X, and then y, and then what happens to each of them. Well, remember, when we go across the x-axis, we take the opposite of the y value. Okay, the x value stays the same, the y value is what changes. So for each of these, A, x is going to stay the same. I'm going to take the opposite of the y, so -3. So A prime is going to be 1 stays the same, and then it becomes -3. B prime, 4 stays the same, and opposite of 5. C prime, -2 stays the same, and opposite of 6. And then D prime, oops, that looks like a P. D prime, now it looks like a B. D prime is -3, -4. All right, and then same is true here for the y-axis, except we do the opposite. We take the opposite of the x, and the y value stays the same. So same on all of these. W prime becomes +3, -2, because the y stays the same, and the opposite of -3 is +3. Okay, Wx becomes +5, -2. Y prime, take the opposite of the x, which is 1, and that stays +2. And z prime, the opposite of 0 is 0, and the y value stays the same. So those are your new coordinates. You can try 15 and 16 on your own for those. And then the last type of problem we're going to look at here, it says the coordinates A, B, C and its image are shown. Describe the transformation. So the pre-image starts here, and we notice here that my x value is, we take the opposite of the x value. Well, when the x value changes, we take the opposite of x value. That means this is across the y-axis. Okay, so that's a reflection across the y-axis when we take the opposite of the x. So, okay, and let's take a look here. My y value stays the same, or my x value stays the same, my y value changes. So that means it is a reflection across the y-axis. Nope, sorry, the x-axis. Y value changes, so it's a reflection across the x-axis. Two more for you to try there.